Today, let's prove an identity in combinatorics. Before we do that, we'll prove a lemma first, which is a generalized version. Then we'll choose special value for P and Q for our desired result. So a general approach is that we choose some generating function. 1 plus x to the power of minus p minus q minus p minus 1, where I require x absolute value is less than 1. So that is equal to this power series. We have the formula. Once we expand that, we have minus p minus 1, choose n. N goes from 0 to infinity. X to the power n. So when you write it down in details, you have n factorial x to n minus p minus 1 times minus p minus 1 minus 1 minus 2 all the way down to minus p minus 1 minus n plus 1. Right. Then we simply take out negative sign from each term. We have exactly n terms. Right. N factorial. This time we start from the last term. Right. It'll become p plus n. Then it'll become smaller and smaller until p plus 1. Now, this is in fact a combination. You have p plus n keeps reducing. Exactly n terms. You have n factorial. It must be p plus n, choose n. Right? But it's the same as if you just say choose p. Right? Because you minus subtract n from here. Symmetric, no problem. Now if I replace x with negative x, right, then my generating function will become 1 minus x to the power of minus p minus 1. Then it'll become negative 1 to the power of n, which multiply this become positive. Right, that's the only difference. P plus n, choose p, x to the power of n. Likewise, 1 minus x to the power of, this time, minus q minus 1. The only difference is q plus n, choose q. Right? So when you multiply them together, minus p minus 1 times 1 minus x minus q minus 1. That is 1 minus x to the power minus p minus q minus 1 minus 1. Now you notice they have similar format compared with this one, except here I have minus p minus 1. Here I have this minus 1. So all I have to do is to treat p as p plus q plus 1 and replace it in here. So that's exactly n goes from 0 to infinity. Right, p becomes p plus q plus 1 plus n. Right, p becomes p plus q plus 1 x to the power n. So when I'm talking about the product of these two, in other words, I'm talking about this infinite series times this infinite series. So when it comes to that, if you look at the product, for example, n from 0 to infinity of some an, let's say, times this series, bn, right? Now, you can think of it this way. a0 plus a1 plus a2 all the way times b0 plus b1 plus b2 all the way. You can treated it this way. So this term times each of these terms. Right, A naught. Then this term times each of these terms. So it's just like a infinite matrix. A naught times B naught. A naught times B1. A naught times B2. Times one more term. A naught times B3. Here. A1 B naught. A1 B1. A1 B2. A1 B3. Here. A2 B naught. A2 B1. A2 B2. A2 B3. Then A3 B naught. A3 B1. A3 B2. A3 B3. Right. So what happens now is that if you want to calculate this, right, you want to add up these all the way, these all the way, these all the way, these all the way. Right? But can you also add it diagonally? Can they equal to each other? Right? You add this term, these two terms, these three terms, these four terms diagonally. Right? So if we assume that this series, let's say real series, is absolutely convergent. Absolutely convergent. Where real series. Then we can say the limit of this series times the limit of that series has to equal to the sum of this term diagonal, this diagonal, this diagonal, all the way. So to calculate it, summing this way, we can simply say that when you fix a diagonal, this diagonal, right? This plus this plus this plus this. Right? The subscript of A just keeps increasing. 0, 1, 2, 3. Subscript of B just keeps reducing. 3, 2, 1, 0. But the subscripts always add up to 3. 1, 2, 3, 2, 1 equal 3, 3 equal to 3. So if we fix 3, K goes from 0, AK times B, N minus K. 3 minus K, for example. Like I said, subscript of A keeps increasing, 0, 1, 2, 3. Subscript of B keeps reducing, 3, 2, 1, 0. But they always add up to 3, right? But you should add this diagonal, this diagonal, this diagonal, this diagonal. Yeah, this diagonal, for example, is 3, but you use n. Right? When n equals 0, when n equals 1, when n equals 2, n equals 3. So in fact, n should go from 0 all the way to infinity. First you do this, then you do that. Right? So this stands for the sum of each diagonal. This stands for all the diagonals. Right? Assuming that this condition is satisfied. So really, like I said, I require x absolute value to be less than 1. And also this power series, whose convergence radius is easily verifiable to be 1. And you have x absolute value is less than the radius of convergence. Of course, both of them are absolutely convergent. Then you can apply. So when you apply, yeah, this time this. So this is my AN, this is my BN. But here, I use AK times Bn minus K. Right? Bn minus K. So perhaps I'll just replace n with K. Replace this n with n minus K. It's the same concept. So K goes from 0 to n goes from 0 to infinity. Right here. So let's just P plus K. P. Q. N minus K. Q. But you have x to the power of k. But here you have x to the power of n minus k. So still x to the power of n. Right? So since they're equal to each other, right? Exactly the same sum, this same sum, same x to n. So this inside bit has to equal to this inside bit. So what kind of special value for p and q can we choose to reach our desired result? So maybe I see this n, maybe I can let p plus q plus 1 equal to n. I just choose some special value. P equal to n minus 1. Q equal to 0. Alright, so let's check. P plus q plus 1, yes, equal to n. So what happens now? Right? Can I just say replace n with m? It's the same concept, right? Replace every n with m, still the same thing, right? Let's say this time k goes from 0 to m. Right? So p becomes n minus 1 plus k n minus 1 times 0 plus this time. Like I said, every n becomes m minus k. 0. So when you choose 0 element, how many ways to choose? One way. So this one. K, so 0 to m and also plus k. Right? So according to this identity, it should equal to this, right? We replace n with m consistently. So p plus q plus 1 and n plus m and down here p plus q plus 1 and this time. Do they equal to each other? Yeah, so exactly what we want.